Okay, number 244. Find the coordinates of the point on the curve y equals x squared minus natural log x, where the gradient is 1. Okay, so let's cheat. Let's go and look at what the curve looks like. So there it is, x squared minus natural log x. And at x equals 1, that's actually the point there, so we can label it. And what is the gradient of the line there? Okay, so that's what we're going to try and work out. What is the gradient of the line there? Because it says where the gradient is 1. Okay, so that's positive. Where's it positive 1? Here. There at the minima is the gradient of 0. This side it's negative gradient. This side it's positive, and we want positive 1. So that's what we're going to try and help the answer for. See if we can get it. So the key thing here is to find the coordinates. So we differentiate to find the gradient function. Now they've used y here, so we'll use that. So y dashed is 2x minus, differentiate natural log of x goes to 1 over x. So that's the derivative function, and we're going to put it equal to 1. So that's going to put equal to 1. And now you have to algebraically solve this. Okay, so various ways of doing this. Hopefully you're confident with your algebra. What I would do is I would treat that as two fractions and then simplify this left-hand side. So what I do with two fractions is I put a line and go 1 times x down the bottom here, put the minus, and then cross multiply. That is 2x squared, that is minus 1. And that there, trust me, is the same thing. And that x can go over here. 2x squared minus 1 equals x. Bring it all to one side. And okay, this is a complex quadratic, and you should be able to factorize this. If it's not factorizable, you'll have to use the quadratic formula. But trust me, this one's going to be a nice one. Whatever way you do it, that's different. That's a year 12 skill basically. But trust me, it factorizes down to 2x plus 1 x minus 1. So if you were to graph that, okay, if we were to just graph that here, say, let's just turn that off. What is it? 2x squared minus x minus 1. And there are the two solutions. One's a negative a half and the other one is 1. Okay, so that's just a graphical proof. Put that equal to 0. And what are the two solutions? This one here gives you x equals negative a half. This one here gives you x equals 1. Now, the problem here is one of those is a dud solution. You know, x cannot equal negative a half. Why? Because of this bit in here. So you can't have negative natural log of a negative a half. That's impossible. So that means the only solution is x equals 1. And if we look at the graph there, there is only one spot where there's a gradient of 1. Just for practice, let's find the tangent line. In other words, this tangent line here. Okay, how do we find this tangent line? We use this formula, y minus y1 equals m tangent x minus x1. Okay, so we've just told the gradient we want it as 1, and we know the in fact, let's finish off the question. It says find the coordinates. Oops, my apologies. The coordinates of the point on the curve where the gradient is 1. So we've got the x coordinates 1. So if I go over here and say y, the y function, plug in 1 into the y function. So that's going to be 1 squared minus natural log of 1. Natural log of 1 is 0, so the answer is going to be 1. So the coordinate point, I'll write it over here, x, y is 1, 1. So that's the answer. Okay, so at the position 1, 1, the tangent will have a gradient of 1. So if we just see that there, so there at 1, 1, the tangent line has a gradient of 1. Now let's get the equation of that tangent line. So what do we need for the equation of that tangent line? We need this formula here. You need to get very comfortable with using this one here. Okay, so this is called the point. You need a coordinate point. You need a coordinate point, and in this case, our coordinate point is going to be 1, 1. So we've got y minus 1. Now, what's the gradient? It's 1 x minus 1. So y minus 1 equals x minus 1. That goes over there. Y equals x. So that is why I've put just here x, and dotted is the way I like to show the tangent line going through there. Okay, that was number 244. Let's go up to here and push stop.